Okay, this lecture is about things that we can find out from ordered data. And so we're going to start out with some definitions. This is just words to help us talk about it. There will be a part on the exam where you're tested over this, the vocabulary. So I would, when you do your study, come back and look through these words. For example, sorting. Okay, this is the act of listing data in a particular order, such as largest to smallest or smallest to largest. The high, okay, is the largest numerical value of a data item. It is denoted by Q4. The low is the smallest numerical data value of a data item. It is denoted by Q0. And the range is the difference between the high and the low. It's the Q4 minus the Q0. And we'll explain here before too long why it's Q4, why it's Q0, why the Qs. And again, we have a Q, the median. It's Q2. The median is the value of the data item that falls in the middle of the data set. If there are an even number of data items, it'll be the average between the two middle data items. Now, if there are n items, the location of the median is computed as n plus 1 divided by 2. If that n plus 1 is not an integer, then you average the data items that are located just above and just below. So like if it's 5.4, you'll average 6 and 5 together. And it would never be 5.4. It'll be 5.5, right? You would average the 6th and the 5th data items together. The median, again, is denoted by Q2. Why Q? Well, it stands for quartiles. We have quartiles, Q0, Q1, Q2, Q3, and Q4. So recall, Q0 is the low of the data set. Q2 is the median of the data set, there, the value in the middle. And Q4 is the high value of the data set. These go in order, right? Q0 is below Q2 is below Q4 in terms of value. Q1 is the median of the bottom half of the data set, and Q3 is the median of the top half of the data set. Now, here is something that will help you. The value of Q0 is always lower than the value of Q1, is always lower than the value of Q2, is always lower than the value of Q3, is always lower than the value of Q4. That they fall in the same, the values of these Qs fall in the same order as the value of the subscripts. Okay. Okay, so what do we have here? We have here on one side, and let me get some colors up here. On one side, we have a data set that we've gotten from somewhere. On the other side, we've taken this same data set and we've put it in order, okay, from low, that's the smallest value, to high. This is the largest value. Note, this right here, this is our Q0, and this right here is our Q4. Okay. Now, what I've done with these, I have these are data. This is data in a spreadsheet, and I've used a spreadsheet to put it in order, and that helps us get this number over here. You can go through and in number counting off things by hand, see where these numbers come from. But you can also use functions within your Excel spreadsheet to calculate this. It'll take the stuff even unordered over here, and it'll calculate your Q0, your Q4, your Q2, your Q1, and your Q3. Here we've got it in order, and so we can do it by hand. We can see, okay, Q Q1, the smallest value is up here. Q4, the largest value is up here. So we're looking for the middle value. The middle, you know, since these are listed in order, we should be able to look here. Gosh, we have 4 columns of approximately equal size. The half of it is going to fall here. Here it turns out that there is exactly a middle item, and that exact middle item is right there, and so that's our Q2. Now that splits it from the top half and the bottom half. The middle of the bottom half is 94. Okay, this guy right here. The middle of the top half, well, it's this guy right here, 139. Okay, and so again, they fall in order. You find where they are to split up your data into the 4 equal pieces. A fourth of your data is below here. Half of your data is below here. A quarter of your data is above this, and this is your top value, and this is your bottom value. Okay, you can encode this on what's called a box and whiskers diagram. Right here, I've made up one where, okay, the smallest data item here, and oh, it's about 12. The largest data item here, and oh golly, it's about 56, 57. Here the median, that line here in the middle, okay, that's going to be about 25. The first quartile here, it falls around, oh, looks about 16, and your third quartile falls around 30. Now the thing is, what does this tell us? A quarter of your data falls between here and here, and another quarter of your data falls between here and here. Notice the top half of this value here, they're closer together. The values are much more bunched there than they here. And again, you have a quarter of your data items fall between these points. This means it's a lot more spread out. You have the same number of data items spread out over a much longer spot here than here. So these things are, you know, kind of spread out over the top. Okay, it's tests frequently fall like this. If it's a hard exam, you have people that don't make very good grades, and so you have people spread out from the top, whereas, you know, if it's hard, you have very few, you have people striving to make a grade, and it's down here. Now over here we have the data we had on the previous page, and this shows that it's fairly equally spread out. You know, this isn't that much more spread out than this, so it's a fairly uniform along the top and the bottom. The middle, okay, here, this isn't all that much shorter than this, so it's much more of a symmetric diagram. And this is, again, it's called a box and whiskers. Well, why? Well, these little things sticking out here are your whiskers, and this right thing here in the middle, that's your box. It sort of makes sense. Box and whiskers. You use your box and whiskers to keep up with your quartile data. Okay. Now, here I have this is a place where my PowerPoint needs to be fixed, but I have scores on an exam that I've listed from the low score to the high score. This is 100, this is 100. I've got my diagram messed up. Okay, and so they're listed in order from low to high, and I've broken them down into things that we're interested in as students: A, B, C, D, and F. Okay. And so I've got these. There were 14 A's. Okay, how do I tell that? Well, 90 and above is an A. You break it right here and you count them. And so you count up, there's 14. B's, well, B's are anything above a 79, so 80, and anything below a 90, so 89. We count 1, 2, 3. So there are 3 in that class, and we do the same for C's, D's, and F's. And the total number of students taking this test was 74. Okay, so we've got this broken down into what's called a frequency distribution table. Okay. Now you can take this frequency distribution table and put it into a histogram or a bar graph. And so I have it listed here, A, B, C, D, and F. And so you can say, hey, gosh, look at a lot of A's here, not so many D's or F's, more C's than B's. But you can tell, and this is in your bar graph or a histogram. And then we have a way of looking at called the relative frequency. Okay, so we take this same set of data, the same frequency distribution right here. This is just exactly my frequency distribution, and I take that and I divide each of these by the total number, and so this tells me what fraction of the total I have here. So like 14 of 27, that's almost 52%. All right, 3 of 27, that's 1/9, that's about 11%, and so forth. For each of these categories, I've calculated the fraction they are of the total. Okay, this is called a relative frequency distribution. So this, if I just have this column and this column, that's a relative frequency distribution. The relative modifying it, saying, okay, relative to the whole. Now, I'm going to put this in a pie chart. Well, what do I do? Well, there are 360 degrees in a circle. I see what fraction of that 360 degrees I have here. So I'd have 187 degrees for A's, 40 degrees for the B's, and so forth. And if I were doing this by hand, I would take a protractor and mark out 187 degrees on it. As it is, we live in the marvelous age of Excel. I just had Excel do this for me. I do this column right here just to sort of relate, okay, what this means. Okay, this fraction of the total, meaning we have 51% of the whole way around the circle, okay, is what we have here. So I can look at this pie chart and say, hey, this category right here, okay, has more in it than all of the rest combined. And this one right here, it's just a little feller in here. It's hardly worth noticing. Okay, and so my D's are hardly worth noticing. My F's hardly more. I've got C's, I've got A's, and a few others. Okay, this final right here is called the cumulative distribution. And what a cumulative distribution does is takes into account what happens up to a certain point. And so I've on this exam, I had it set up maximum of 100 points, and so I break up my class here into 10, 20, 30, 40, 50, 60, 70, 80, 90. And notice we didn't have anybody make below 40, and so it just stays flat along here. Nothing happened below 40. I had one person make a 49. I then had 3 people who made less than 60, 3 people who made 4 people who made less than 70, 10 people who made less than 80, 13 people make less than 90, and then 27 people made 100 or less. Okay, and so that's how this is broken up. Okay, and now you take this cumulative frequency distribution, that's what this table is called. We take that and we graph it just with the the x coordinate being, okay, this score break here, and the y coordinate being the thing in the cumulative frequency column. And we mark these across here and into this. This is called an ogive. Okay. Now, what you know, an ogive always goes up, and how you tell anything from it is how rapidly it goes up. You see, this right here, okay, is more steep than this right here, and so that means you have more items there, and so forth. Okay, and so these all tell you, these ways all are good ways of keeping up with different ways of information.